Hello, my name is Austin Garcia, and this is my final for applied predictive modeling. So for this data dive, I decided to use the Titanic dataset, and I used classification to create models that would predict if a passenger survived the Titanic or not. So we have part one here for EDA. Distribution of ages with a histogram. We can see most of the ages here are between 20 to 40. Some pie charts for the proportion of survivors grouped by gender. So you can see mostly females that survived. And then for deaths, it was mostly men, 84% that passed away. So for here, we have the deaths and survived broken up by class. So first class, second class, third class. First class would be the most expensive tickets, which we see that 61% actually survived in class 1 versus 57% that died in class 2. And then third class, 74% or rounded 75% passed away in third class. Then we have here the histogram for number of survivors by age group. So these are the ones that survived, these are the ones that passed, and mostly people within 20 to 40, which going back to that histogram I made earlier, we can see that a lot of the people on board the Titanic were between the ages of 20 to 40. So it makes sense that most of the deaths and most of the survivors would be people within that age group. So this one is proportion of deaths between male and female in third class. So yeah, 80% of men in third class died compared to 20% women that died. So for here we have a correlation map, and the highest correlation is seen with gender, which again, just looking over all those graphs I made, it is very easy to see why that would have the highest correlation. So from cleaning here, I dropped name, ticket, cabin, body, boat, filling nans appropriately. I had quite a bit of nan values. You can see like this one just has like 1 or 2 versus home destination, which has 564. So this one filled in the nans with the average age. This one, let's see. So this one was SCQ, and then I just took the mode since S appears way more than any of the other ones. Then home destination, I tried to distribute it evenly and to maintain the integrity of the original distribution. So that was the one that I did for that. And then, so checking nulls, there's now no more nulls. So filtering for the outliers, we can see here that some of these did have some outliers. Age, and that's just to be expected that there would be outliers there. But SIB, SP, which means how many siblings they had or spouses they had on board. You can see a few outliers here. Same thing with Parch and Fair. So those were the 3 ones that I filtered out. Feature engineering, we already encoded P class and sex whenever I did the correlation map, so I just dropped the original columns for those. And then here I had to do some more encoding. And I did some scaling as well, min, max, and standard scalar. And here we get to the modeling section. K&N performed the worst out of all the models with 69% accuracy on standard, min-max, and unscaled data frames. Next we get to decision tree, and on the unscaled it got 80% accuracy, and then for min-max and standard it got 99%. And I talk about this in my summary and within Markdown that I didn't think that sounded right. I am not at the skill level to produce models with 99% accuracy. So just something about that did not seem right to me. And so I used a holdout validation to test the unseen data, to test for overfitting. And when I did that, I got 80% on both standard and min-max. So that is way more in line with what I got for the unscaled data frame. Random forest, I got 84% on standard and 84% on the unscaled. At this point, I decided to stop doing the unscaled, or not unscaled, I forgot this. I stopped doing min-max because I didn't think that it kept getting the same thing as standard, so I just didn't see a point in doing both, so I just stuck with standard. Linear regression, a 83% for the unscaled data frame and 82% on standard. I talk about this in the summary, but the unscaled and standard just kind of when sometimes the unscaled would perform better, sometimes they would perform the same, other times the standard would perform better. So it just depended on what model I was doing because it did kind of change. Light GBM, when I did a light GBM model on my last data dive, that was when I got the highest overall accuracy on. And on this data dive, I did get the highest at 85% for unscaled and then 86% for standard. And then the last model here I did was naive Bayes, which got an 80% overall. So, my conclusion is that light GBM performed the best overall. And if you used scaled or unscaled data, it just depends on which kind of model you're building because it did fluctuate. Those two would fluctuate over which one would do better, or sometimes they would just do the same. And then when it comes to scaling, it doesn't matter if you do min-max or standard because they are performing the same either way. And yeah, that is my conclusion. Thank you for listening. Thank you for a great semester. Goodbye.